Medical news from circulation. Contrastive machine learning to quantify hypertensive multi-organ damage and identify new disease phenotypes, a multinational multimodal study. Researchers have made a significant breakthrough in the field of cardiology by developing a novel machine learning approach that can quantify the extent of multi-organ damage caused by hypertension, a condition that affects millions of people worldwide, and identify new disease phenotypes, which is crucial for preventing vascular events and death. This innovative approach matters because it has the potential to revolutionize the way hypertension is diagnosed and managed, enabling healthcare professionals to identify individuals at high risk of developing severe end-organ disease and provide personalized interventions. The burden of hypertension is substantial, with evidence suggesting that it is a major risk factor for cardiovascular disease, kidney disease, and stroke, making it essential to develop effective strategies for early detection and prevention. The study was needed because hypertension can cause subtle structural and functional changes in multiple organs, including the heart, brain, kidneys, and vasculature, which can be difficult to detect in clinical practice, and existing risk scores have limitations in predicting disease progression. Previous studies have shown that subclinical damage can increase the risk of vascular events and death, highlighting the need for a more sensitive and specific approach to diagnose and monitor hypertension. The development of a machine learning approach that can quantify multi-organ damage and identify new disease phenotypes is a significant step forward in addressing this knowledge gap. The study used a semi-supervised contrastive trajectory inference framework to analyze data from 27,099 participants in the UK Biobank imaging substudy, which included 566 multimodal imaging and non-imaging variables, and validated the model using data from 5,507 participants in the atherosclerosis risk in communities study. The researchers developed a global organ damage score, known as the hyperscore, which was able to quantify the extent of multi-organ damage and predict disease progression trajectories. The model was validated through multiple internal validation steps, and its external validity was tested on the ERIC study population, demonstrating its robustness and generalizability. The results showed that the hyperscore achieved an area under the curve of 0.964 for identifying individuals with severe end-organ disease, indicating excellent predictive performance, and had robust stability in cross-validation with a mean root mean square error of 0.104. The survival odds differed significantly across hyperscore stages, demonstrating the clinical relevance of the score. The study also found that the hyperscore was able to predict incident multi-organ disease and survival for up to 7 years, across both the UK Biobank and ERIC study populations. The study also identified distinct hypertension-associated organ disease phenotypes, which could have important implications for personalized medicine and targeted interventions. For example, the researchers found that certain phenotypes were associated with a higher risk of cardiovascular disease, while others were associated with a higher risk of kidney disease. These findings suggest that the hyperscore could be used to identify individuals at high risk of developing specific types of end-organ disease and provide targeted interventions to prevent or slow disease progression. The clinical significance of this study is substantial, as it has the potential to change the way hypertension is diagnosed and managed in clinical practice. The hyperscore could be used to identify individuals at high risk of developing severe end-organ disease and provide personalized interventions to prevent or slow disease progression. The study's findings also have implications for guideline development, as they suggest that a more nuanced approach to hypertension management may be needed, taking into account the individual's risk of developing specific types of end-organ disease. However, the study has some limitations, including the potential for bias in the study population and the need for further validation in diverse populations. Additionally, the study highlights the need for further research to fully understand the clinical implications of the hyperscore and to develop effective strategies for implementing it in clinical practice. Thank you for watching. For the full article, visit MedMind AI at medmind.pro. Like and subscribe for more evidence-based medical content.